In this lesson, we're going to talk about carbon bonding. And so the first thing that we're going to cover is how we classify some of the different carbons. And so we have primary, secondary, tertiary, and quaternary. And so these definitions or classifications are given based on the number of carbon neighbors that a specific carbon has. And so a primary carbon has one carbon neighbor. A secondary carbon is going to have two carbon neighbors, and tertiary will have three, and quaternary will have four. And so if we look at this diagram of the structure drawn below, we can see that this carbon right here is a primary carbon because it's bonded to 3 hydrogens and 1 carbon, so it has 1 carbon neighbor. And then this carbon is a secondary carbon because it's bonded to 2 hydrogens, but then it has 1 carbon on each side of it also, so it's bonded to 2 carbons, making it secondary. And then this carbon in here, we can see is bound to 1 hydrogen on the right side, and then it's bonded to 3 carbons, making it a tertiary carbon. And finally, this last carbon up top is a quaternary carbon because, as you can see, all 4 of its bonds are with other carbon atoms. And so if we look at the stability of these and rank them based on how stable they are, a quaternary carbon is the most stable and a primary is the least stable. And they just go in decreasing order from there. And this kind of makes sense because, again, if we look at this diagram of our quaternary carbon, it's going to be a lot more stable if each of its 4 bonds are shared with the larger carbon molecules compared to the primary where 3 of its 4 bonds are shared with the small hydrogen atoms. So this is how they rank in stability. As far as structure goes for carbon bonding, we can have chains, which will just be a chain of carbons like this. They can also be drawn with kinks in them, but they're still just a chain. However, a branched can sort of look similar. This is how a branched chain will be drawn. And so it's sort of similar, but we just have branching off of certain points rather than just a straight line chain. And then a ring would look something like this, and then bound to hydrogen on the other remaining bonds. And then we can also have something that's called epoxides, and so their bonding structure is going to look like this, bound to this oxygen up top, and they form like these little triangle structures. And so now, finally, if we look at the different types of bonds, we can have single, double, and triple bonds. And if we compare them lengthwise, a triple bond is the shortest of these 3. And a single bond is the longest. And obviously a double bond is in between the 2. And as far as energy, a single bond has the lowest amount of energy, and a triple bond has the highest amount of energy present. And so this makes the strength of the bonds different also. So the single bond, which kind of makes sense, is the weakest, and the triple bond is the strongest. And so this strength classification comes off of the fact the length and the energy present in each of the bond types. So a single bond is the longest with the lowest energy, so it's the weakest. And a triple bond is the shortest with the highest energy, making it the strongest type of bond that we can have.